motion in space. We did derive it, we got it. This was a pass thrown that went in a football game. It was December 3rd, 2015. That was the last play of the game. So it's the old, what, Hail Mary? And if you wonder which two teams are playing, this was Packers versus Lions.
Oh.
Maybe you've seen this play, but it was a pass by Aaron Rodgers. I mean, he's way down the field. So this is what happened. We're just going to throw a Hail Mary. The angle of elevation is 55 degrees. The initial speed was 25.4 meters per second. What was the distance down the field that he threw this thing? And when he launched this thing, it was, I'm going to put it in meters, 61.27 meters downfield, there was a receiver. So I'll just put parentheses. There was a receiver standing 61.27 meters downfield from Aaron Rodgers. Okay. And he threw the ball from 2 meters in the air. So what's the initial height?
2.
So when he threw the ball, from 2 meters, just in height. So I'm going to start drawing this. X-axis, Y-axis. I'll start here at the origin. How high was it before it got launched?
2 meters.
2 meters. Boom. And he throws this thing. There's a receiver 61.27 meters downfield. Let's put a receiver down here. And let's say, I'm going to throw a math problem, that this receiver can catch any ball between 0 and 3 meters. The receiver can catch any football standing downfield between 0 and 3 meters. Why so high, everyone?
Jump.
You know, meters long, he can jump, right? He can jump pretty high. All right. Aaron Rodgers is the quarterback, going to launch it from 2 meters. Angle is what?
55 degrees.
55 degrees. Angle of elevation. Initial speed, 25.4 meters per second. Last pass of the game. The receiver can catch anything between 0 and 3 meters. So the question is, did he catch the ball? That's what we want to see. All right. I do want to point out, let me write it again. The receiver, or mention it again. I'll write it on the board. The receiver can catch any ball between 0 and 3 meters. Just think vertically. Okay. So I'll start with this. Let me write it all out. Now let's describe this pattern. RT. That's the x component. 25.4. You have to put the units. Cosine of 55 degrees times a variable 2. What's the y component? 25.4 sine of 55 t minus, what's 1/2 of, we're going to use 9.8 for g. So I'll put minus 1/2 9.8, feel free to put 4.9. And then t squared. Did I forget anything?
Yeah, plus the initial height.
This
2.
is huge, so be careful that not everything's thrown from the ground. Although we will do some problems today when we're thrown from the ground. This was launched from 2 meters in height. So right here in this y component, I'm just going to add up 2. All right. Yeah, there we go. Now, did the receiver catch it? Did he catch it? Where should we start? Yes or no? We've got to justify this. Did he catch the ball? Where should I start? I've got the distance x, right? You want to start there? It went 61.27 meters. What can I set it equal to? This right here. What can I solve for?
T.
T. So let's start there. We can actually solve for T and figure out the time it took for that ball to what? Travel all that way. I know it's going along that arc, but we can find the exact time that it took to get down there. 61.27 meters. Perfect. So I'm going to write 25.4 cosine of 55 degrees. Times T, and set it equal to 61.27. So what's T? 61.27 divided by 25.4 times the cosine of 55. Make sure your calculator's in degree mode. And when this is interesting, those last problems we just did with the arc length, we want those, if you're going to use a calculator, in radian mode. We go one section further in 13.4, looks like we're going to use a calculator, we're going to have everything in degree mode. So let me just make a note of that. Calculator, degree mode, for 13.4, and we're just going to have it in radian mode. Why didn't we have errors if anybody in here had to calculate in degree mode in the last section? Because we did most of those problems by hand, didn't we? We did most problems by hand. We only did that one with the e to the t. We don't need that in radians. Right? We in degree mode or radian mode. We didn't have any trig functions we entered into the calculator. Hey, what do you get for t? So 4.21 seconds. And he rounded it. What was before that? 4.2055?
2055505.
So I went over 4.2055 seconds, but he's like, hey, listen, it takes roughly 4.21 seconds to get down here. Okay. Now, how can we use that to help us answer this question? We know it takes 4.21 seconds to get to here.
Plug it in for T and the Y.
Plug it into the y component. Very good. Plug it into the t and the y component. And that will give us the height at that time. Sound good? Now let's do this, and let's discuss this. Let's say I get a number like 8. What's the answer?
No.
Whatever it's at, right? What if I get a number like 2.5?
Yes.
He caught it. So it's 0 to 3, he catches it. Above 3, whenever his head. Help me out with this. What if we get a negative value? That throws people off on the test.
No.
What if you get a negative value? What does that mean? What happened?
It fell on the ground.
There you go. Everyone's saying the ball fell down short. It would have hit here, and just, it's indicating that it would have rolled or something right along the ground. That's what the negative, which means incomplete, right? Excellent. And we're not worried about like the defenders, like interception. We're just saying, hey, this guy can catch this because in reality on this play, everyone did just jump. Everyone just jumped up. But the Packer receiver did get in front of everyone before he launched up, you know, like this. All right, so let's do that. You got your calculators? Let's put this in there. Put it there and put it here, and don't forget the plus what? 2. So what's 25.4 sine of 55 times, and when I just store this in my calculator to some letter like what? X? Do you do that? I'll store this number to X, and I'll go 25.4 sine of X minus, times sine of 55 times X minus 4.9 times X squared plus a what? 2. I'll type it like this into my calculator, but I stored this number without even rounding it to some variable like X. Cool. You know where the stow button is on the calculator? Yeah, good. All right, what's the height? What's the height of this ball?
Like 2.747.
What do you don't think? Did he catch it?
Yes.
Yes! Catch! He caught the ball! Cool. And we'll play with this problem a little bit too, but anybody want to see the play?
Yeah, sure.
Okay. Let's just see. It's cool. Doesn't take much time. We want to see this play. Did he really catch this thing?
I'll turn the cam off for a second.
Is it far enough, that projector?